kids, Miss Kulkarni here. So today we are going to talk about stoichiometry, and in this stoichiometry we are going to use dimensional analysis, which you already have learned so far, and we are also going to use it for converting moles to mass and of course mass to moles, and also we are going to have moles to particles and particles to moles. So let's begin. Are you ready? So what is a mole? A mole is nothing but a simple unit which we use in chemistry. Just like instead of saying cups of flour or 2 tablespoons of oil, we use moles when we talk about chemicals. It's also called as a counting number. That means just like we say dozen eggs, 1 dozen means it's 12. There are also some new terms you'll be learning in this unit. One of them is Avogadro's number. I call it sometimes as avocados. So Avogadro's number tells you that 1 mole of any chemical substance will be always equal to this many particles, which is 6.022 10 to the power 23 particles. And it also talks about something called molar mass. And what is it? The molar mass is of course the mass of 1 mole of a substance. Okay, let's talk about the atomic mass. The atomic mass is nothing but it is the mass in grams for 1 mole of an element. And how do we represent? We usually represent this to the 100th place, except for hydrogen, and we always have the units labeled as grams per mole, which indicates it is the mass for 1 mole of any chemical substance. Also, the atomic mass is mass of 1 mole, but that means how many particles we got, which is the big fat number, Avogadro's number, 6.022 10 to the 23 atoms. Let's find out atomic mass for the elements now. And what do? We simply look in periodic table and we're going to look for the symbol and find out the atomic mass. Xenon is Xe, so you're going to look for xenon, and what we found out was the mass was 131.29, and of course the unit was grams per mole. Then we look for boron, and boron is of course B, and the mass was 10.81, and then so on. Gold is Au, and then gold atomic mass is 196.97. Then we look for arsenic, which is As, and that is 74.92. What about magnesium? The symbol is Mg, and when we look in periodic table, that gives you 24.30 as the atomic mass. One more remaining, tungsten. That's the weirdo. Tungsten is only W as the symbol. So when we look for tungsten, the atomic mass which we find is 183.85, and again the units for the mass is grams per mole. So you know now how to find out the atomic mass for an element. Let's make it simple. We need to know how we convert from moles to gram or grams to mole. We also need to know how we convert moles to atoms and atoms to mole. And remember, they are all related, they are connected by the certain constants. Moles to gram is connected by molar mass, and moles to atom is connected by Avogadro's number. So 1 mole of carbon, what's the amount in gram? That's the mass of 1 mole, which is the atomic mass for carbon, which we know from periodic table will be 12.01 grams per mole. And then how many atoms it will have? It's 1 mole, so that will be Avogadro's number, which is 6.022 10 to the 23 atoms. This is actually the atomic mass for sodium. That means what we have is 1 mole of sodium. That's what we have, 1 mole of sodium. And 1 mole of sodium will be equal to how many particles? 6.0 to 10 to the 23 particles. Let's complete one more thing. We know now the particles, and very much we discussed about this, that if it's a 1 mole of any element, then number of particles is going to be Avogadro's number. So we must have 1 mole of barium. And then how much will be the mass for barium? We are going to look in periodic table to find out the atomic mass, which is 137.33 grams. So there you go. Now you can find out the unknowns between moles, grams and atoms for any given element. Alright, now we are going to begin with the main conversion problems, which is of course dimensional analysis. Did you see what it says? I am drawing this as a mole, and I'm saying the mole is the heart of chemistry. Just like our body, the blood passes through heart either way. So same way, when you do some conversion, we are going to always pass through this heart, which is a mole. So if you want to go from particles to mass, we are going to go from particles to moles and moles to mass. Or if you want to go from mass to particles, we go from mass first to moles and moles to particles. In this video, we are only going to focus on one-step conversions, either particles to moles or moles to particles, and from moles to mass and mass to moles, to make it simple. Let's focus now on one-step conversion from moles to mass and mass to moles. Now here is some suggestion I'm going to give you. The main thing is, if you read the problem and there are some numbers given, always circle those. Like this one is asking you how many moles are there in 28.7 grams of lithium. I need to begin with this 28.7 grams, that's my starting point, grams of lithium, and my final destination is going to be moles of lithium. So let's begin with our grid. We begin with the grams of lithium. Our end point is going to be moles of lithium. Remember, we need to cancel grams of lithium. So crisscross, what we should get here is grams of lithium. And as I told you, whatever is given to you, that's your starting steps. So 28.7 comes over here. Now the question is, what goes over here? Moles of lithium and grams of lithium. Did you see what I wrote over here? That's an equation. 1 mole of lithium is equal to 6.94 grams of lithium. So we're going to put the coefficients right over here. So that's your 1 mole of lithium. And for grams, you're going to put that as 6.94 grams. How did I find out this equation? It is simple. We just look at the periodic table and look for lithium, and this is the atomic mass for lithium, which is given as 6.94. Now we are back to simple algebra. So grams of lithium unit gets cancelled just like algebra, and we are left with these two numbers. We're going to divide these two numbers, and your final unit is going to be moles of lithium. So when we do that, your answer comes out to be 4.14, and that is moles of lithium. Isn't that simple? Let's do one more problem. So in next problem, we have some guy, Rufus, has measured 79.83 grams of potassium, and we have to find out moles. You need to know what is the symbol for potassium. Do you remember that? That is Miss Kulkarni, Miss K. Is potassium is called as K. So in periodic table, you're going to look for the atomic mass for potassium, and I'm going to give you right now. You will find that mass as 39.10 grams per mole. Let's go back to our grid, and remember we always begin with the given. So that is grams of potassium, and I like to put the symbols instead of putting full word potassium. You can write potassium if you like to. And then my destination is going to be how many moles. So I'm going to put moles of potassium. Just like algebra, we need to cross out grams. So grams of potassium comes over here. Remember, we begin with the given, which is 79.83 grams. And what goes here? This is 1 mole. It's always going to be 1 mole when we talk about the molar mass or atomic mass. And grams is the atomic mass for potassium, which is 39.10. There goes grams of potassium. And what you are left with is these numbers. We divide, multiply, and your final answer is going to be moles of K. So I believe I got this as 2.042 moles. That's bingo. We got it. Let's move on to the next one now. Alright, this is going to be from moles to grams now. So what do we have? We are beginning with aluminum. Do you remember the symbol for aluminum? It is Al. And we are given 1.8 moles, and we need to find out the grams. So your roadmap is going to look as moles of aluminum going to grams of aluminum. Let's get everything into the grid. So we are beginning with moles of Al, and destination is grams of Al. We need to crisscross cancel, so this comes moles of Al. What do we begin with? That's the given, so it will be 1.8 moles. And what do we get here? Remember, mole is always going to be number 1, and this will be the molar mass for aluminum, which I believe is 26.98. For the next step, you cross out the moles unit, and now you are left with these two numbers. You're going to multiply that, and your answer is in grams of Al. So when I multiply 1.8 times 26.98, I believe what I got was 48.56 grams. Was that easy? So guess what? We already figured out how to go from moles to mass and mass to moles using, of course, molar mass, or in case of the element, it is atomic mass. Let's focus now how to go from particles to moles and moles from particles. So our first question is, how many moles are there in these many atoms of silicon? And to help you, already I gave you 1 mole of silicon is equal to 6.022 10 to the 23rd atoms of silicon. How did you get that number? That is the Avogadro's number. So I am going to directly go to the grid now, because that's something will save me some time. My given is 1.28 times 10 to the 24, and that is atoms of course, silicon. I'm going to make sure I put silicon there. And my end destination is going to be moles of silicon. So now you know very well what comes here. This has to be atoms of silicon underneath here. What goes over here? Remember, it's 1 mole of silicon is equal to the Avogadro's number, which is 6.022 10 to the 23rd, so many atoms of silicon. We are going to cross out the units, and what we are left out, we are going to actually divide those numbers, and what we end up getting is moles of silicon. So the final answer which you're getting is, I believe, is 2.13 moles of silicon. Let's work on some more practice now. Here the moles are given for cadmium. Okay, not candium, cadmium, for which the symbol is Cd. And now let's find out how many atoms it has. So I am going to again directly go to the grid, because I know the roadmap and you should know the roadmap too. So I am beginning with the moles of cadmium, and I need to go to the atoms of cadmium. So I'm going to begin with the given, which is 0.00375, and over here I need to crisscross cancel, so that means I need to have moles of cadmium coming over here. How do we put the values here? Remember, 1 mole of any element, any chemical, is going to be equal to that big fat Avogadro's number, which is 6.022 10 to the 23rd. So now the next step is you're going to cross out moles of cadmium on both sides. You got some mathematical numbers there. You just have to multiply those and your answer will be atoms of cadmium. So which I believe I got the answer 2.26 10 to the 21st. That is atoms of cadmium. Let's work on one more problem together, and I am sure you are going to master this conversion. So this one is about carbon, and carbon symbol is C, and atoms are given to you. You need to find out the moles. So my grid is going to be atoms of carbon. Remember, my destination is moles of carbon, and crisscross I need to cancel out, so I got atoms of carbon over here. I begin with the given, which is 4.55 10 to 24, and over here remember mole is always going to be number 1, and when it's atoms of carbon, what do we write? It is that Avogadro's number, which I think you already memorized by this time. So atoms of carbon is crossed out, and now we got two numbers. We just divide, and your final unit is going to be moles of carbon. And then my final answer is 7.56. So there you go. I hope you guys enjoyed the video, and I am pretty positive you understood how to convert moles to mass or mass to moles, and also moles to particles or atoms, and atoms to mole. Well, I'll see you guys in next video. Until then, bye bye.